Okay. Hello. Oh boy, lighting. That is rough. All right. Hi. Okay. This lesson is about being able to explain and apply congruence and the criteria for congruence in terms of rigid motions. Okay, we're going to focus mostly on this word congruence. So as a reminder, we'll get into this in a second, congruent is when two objects are the same size or shape. So for example, I got one pip up here. Oh man, here's another one. They're twins, right? Hey, these two piplets are congruent. They are the same size and the same shape. They are identical, right? Okay, cool. So let's start with, so we're going to basically be exploring specifically a lot of congruent triangles today and what is true about congruent triangles and how we can like tell if they're congruent and say they're congruent. All right, so we'll start with our important vocab. So just a reminder, if we've got a triangle ABC, so we've got A, B, C. So sides are basically, if I think about these three dots, if I connect two dots, I create a segment. That's an example of a side. So a side is like from A to B. You can call that A to B, segment AB. Now an angle, so if I have that same triangle, A, C, B, with three corners are A, C, and B, and let's just say I focus on one of the corners at C, the corner that's created here, and then the arc between the two corners, like the rotation it would take to go from there to there, that's an angle, and we can call that just angle C. Okay, congruent, we already talked about same size and shape. Symbol for that is a squiggly line and an equal sign. Next, let's look at congruent segment and congruent angles. Let's take it back to triangles. If I want to say two sides are congruent, which are, again, segments, so let's say I want to say these two sides are the same length in this triangle, I can put tick marks like that to show. Or I can double the tick marks. It doesn't matter. If I do that, that is saying that the two sides are different. I want to make them the same. They're just saying the same number of tick marks. For angles, I take the same triangle, and now I want to say these corners are the same size. These corners like open up the same way. I put arc marks like that. And again, it's just about the same number of arc marks. I could put two if I wanted, or I could put like a little dash on the arc marks. Just essentially if they have the same symbol, that means those two angles are opening up the same amount. Okay, opposite refers to across from, and in triangles we do a lot of like, if we're at an angle, so if we're at one of these corners again, which side is across? It's kind of like you can use the arrow to help yourself see that. Corresponding means matching. Use that a lot today. And then triangle sum theorem. So that is, again, if I have my three triangles and I have A, B, and C, basically A plus B plus C has to equal 180. And again, that's the inside numbers. So like A, B, and C, those angle measures inside, will always add up to 180 in a triangle. All right? So we're going to jump to our first key points box. All right? So first we're going to just define congruence, okay? Two figures are congruent. So same size and shape. We can use this symbol again, to each other if a sequence of rigid transformations will map the first figure completely onto the second. So transformations are, again, when we like move a figure by either sliding it, flipping it, or turning it. That's a rigid transformation. We're not changing the size or shape. So here, if I want to know if these two figures are actually congruent, if I can perform some transformations and see that one figure will like lie completely on top of the other figure, then I can prove that. So I'm going to use some patty paper to see if I can like make that happen. So here I'm going to trace this first figure. My pencil real quick. Okay, and then let me see if it maps. Here, I'm going to outline this so I can see it a little more clearly. I'm going to see if I can like, if I move the patty paper around, if I flip it, rotate it, or slide it, if I can make this finger go onto that figure. Now, when I look at the two figures, let me just think, like, does a slide work? No. Does a flip work? No. What if I turn it though? Okay, so if I do some turning, I start seeing that maybe the figures are kind of the same. Okay, and then if I slide it, oh man, yup, I see that the penciled figure completely overlaps the green figure. So that means these two, we can know that these two are congruent. So basically they are congruent because if you do a rotation and a translation, so if you turn it and slide, if you turn and slide the first figure, it maps onto the second figure. So that's the sequence of rigid transformations that would map the first figure onto the second and say that these two shapes are actually congruent. Okay? We're going to jump to the next key points box. Now, the next key points box is about like, well, what if I don't have my patty paper, but I still want to say two figures are congruent, like on paper? So there's a couple ways to do that. First, a congruency statement is used to say that two shapes have that same shape and size, basically are congruent. And it's written in a way so that corresponding, again, matching vertices, I'm going to actually write the word matching underneath it, matching vertices are in the same order. All right, so if I look at these two shapes and I want to know if they're the same size or shape, and again, I'm not going to use the patty paper to determine it, but I am noticing something. I am noticing that there are 3 ticks here, 3 ticks here. So these two sides must be the same, right? I'm noticing 1 tick here, 1 tick here. So AC has to be the same size as GE. And then I'm noticing BC and FE both have 2 tick marks. So BC and FE are the same length. So they have 3 sides that are the same. Okay. Now let's look at their angles. I'm noticing angle B and angle F are the same. They have the 1 arc mark. I'm noticing angle C and angle E are the same between the two triangles. And I'm noticing angle A and angle G are the same between the two triangles. Okay, so this means these two triangles are identical. They have to be the same size and shape because between the two in the set, they have 3 sets of corresponding sides, matching sides that are congruent, and they have 3 sets of corresponding angles or matching angles that are congruent. So I know that these shapes are congruent just by the tick marks. Now, I can use, again, a congruency statement, which is, congruency statement is basically what's happening here and here, okay, to say that these two triangles are congruent. And again, the way these are written is the corresponding, those matching vertices are in the same order. So when I look at the triangle, and this says triangle ABC is congruent to triangle GFE, the order of the letters matters. It's basically telling you that, hey, A is listed first, G is listed first. Those two angles need to be congruent between the two triangles, which we see in the picture. It's then saying B is in grade. B is second, F is second, and look, B and F are congruent between the two pictures. And then lastly, C is last, E is last, and notice C is congruent to E. Okay? The same holds true for the sides. Look, AB are the first 2 letters, side AB is right here. GF are the first 2 letters, and GF is the side that's congruent to AB. Or we can see BC, does BC match FE? BC matches FE, yes it does. And then does AC, first and third, match, is it congruent to GE in the picture? Yes, AC goes with GE. Okay? Now, it does not matter the way that you list the vertices. Like, they're not always going to be listed alphabetically. Like, here it's alphabetically, but what if I switched up the order? So if I call this CBA, well, then that just means if I call the first triangle CBA instead of ABC, which is fine, then I just have to rearrange my order of the second triangle to make sure that those vertices, again, match. Those corners match. So C is with E, right? Does that make sense? Yep. C and E are congruent, right? B is now the second letter, so F remains the second letter, but now A is the third letter, so G now has to be the third letter, okay? Now let's look at this congruency statement. I'm noticing there's a check here, and an X here. I'm wondering if this one is wrong. So this says A, B, C, right? So A is supposed to go, does A go with E? No, it doesn't. Does B go with F? I mean, yes. Does C go with G though? C does not correspond or match with G. Oh, sorry, G is pink. Okay. So I'm just using color coin to help myself see that. So this congruency statement does not accurately describe this picture of these two triangles. Okay. And basically we can sum up everything I was saying with this thing called CPCTC. That is just a shorter way of saying corresponding, again, matching parts of congruent triangle. Well, what am I writing? Sorry, that is not the word congruent. Sorry, congruent triangles are congruent. Okay. Cool. Another way too that we can see it. So a lot of this is going to be about, guys, like figuring out what parts match each other between the two triangles. Like what angles match each other and what sides match each other. Again, if you're given a congruency statement, you can just follow it. Or if you're already giving a picture with tick marks, then you can just follow the picture. Sometimes you might be given less information than that though. And so another way that you can see what parts of the triangles match each other is by looking for included sides and angles. So basically, the angles and sides, this is just the angles and sides included between two angles and sides. So basically, angle B, it's the included side for sides what? It's basically in between side CB and BA, right? Okay. So basically this can help me talk about like position, where stuff is located in the triangle. What about angle C? Angle C, right? It's in between, it's smashed, that arc is smashed in between CB and CA. And then angle A is right here, right? That arc, I should be giving these all this stuff different. Sorry, arc marks, because we don't know these angles are the same. Okay, that arc is smashed between side CA and side AB. Okay. Now let's do the same thing for sides. So side CB is the included side for angles. So CB is right here. CB is in between C and B. Basically, it's endpoints. So angle C and angle B. And angle B. BA is in between B and A. And then side CA is in between C and A. This might seem really obvious. This will just be helpful later when, again, our pictures are less clear or we don't have congruency statements. It'll help you maybe see what parts match each other or correspond between those two triangles that are congruent. All right, let's do an example now. So basically, example C says, let triangle DOG be congruent to, I see the congruency symbol, to triangle CAT. So respond to the following. It wants to know what angle is congruent to each other, what sides are congruent. Ooh, I'm given some measurements and then asked to find a measurement. And then I'm given some side lengths and I'm asked for the perimeter. All right, so first thing I notice, I don't have a picture. So I'm going to draw myself a picture. And I'm going to make the picture really clear. It goes D-O-G. D-O-G goes with C-A-T, dog, cat, haha. So I'm going to make my corresponding parts like be the same in the same spot in the picture, right? Like D is lower left, so C is lower left. O is up top, so A is up top, and so on and so forth, okay? I'm not going to rotate the other triangle. That's just going to make it confusing for me, okay? Now, first thing, and then what I'm going to do next is I'm going to add tick marks to help myself see what is congruent in these two triangles, okay? So D and C are first, so D matches C. Now, I'm going to show you something. I could follow the congruency statement, or if I look at the side opposite D, right, that's OG, the side opposite C then has AT then has to be the same. So because these two angles are the same size, so they're opening up to the same like width of OG and AT. That's another way to see corresponding parts. But I'll follow the congruency statement. Okay, O and A have to be congruent, and then G and T have to be congruent. Okay, cool. Now let's do sides. DO, first two letters, CA. So DO and CA are congruent. OG, second and third. AT, second and third. And then DG, first and third. CT, first and third. Okay, so now I've labeled all the parts so I can see which parts match, which parts correspond. So now this is really easy. What angle is congruent to angle T? Angle T is right here with the 3 arc marks. Oh, that's angle G. What angle is congruent to angle O? 2 arc marks. 2 arc marks is angle A. What side is congruent to side DG? DG is right here with 3 tick marks. CT has 3 tick marks. And again, I use the congruency statement to label that stuff. And then what side is congruent to TA? Ooh, TA is right there with 2 tick marks, so OG. Notice TA, it could be AT. You can flip the order. Okay, now it says, given the measure of angle O is 60 and angle G is 40, what is the measure of angle C? All right, so let's label my picture. So, what's it saying? Angle O is 60 degrees, and then angle G is 40 degrees. We want the measure of angle C. Okay, so, well, how am I going to do this? Well, what I'm noticing is that C is in cat, the cat triangle. I don't have any angle measures in here yet, but hey, A and T are congruent to O and G. So this must be 60 and this must be 40. I'm allowed to if the angles are congruent, their measures are going to be equal. So now I'm noticing, oh, hey, I got 3 angles. Well, sorry, I got 2 angles inside cat. 60 plus 40 plus the angle I don't know, let's call it C. They have to equal to 180. So then that's 100 plus C equals 180. Subtract 100, subtract 100, and C is going to be 80 degrees. Okay. Now let's do part D. It says given DO is 2x plus 1, so let me label that 2x plus 1. And it says CT is 8. Okay. And then it says CA is 3x minus 2. AT is x plus 10. What is the perimeter of DOG? So to get the perimeter, I got to add the 3 sides of DOG. And I only have information about one side so far. And it's an expression with x in it. So basically my mind is like, okay, well, I need to know how long DO actually is, OG actually is, and DG actually is. Like, can I solve for x? So let's see if I can set up an equation. If 2 parts are congruent, then their quantities are going to be equal. So I'm noticing right now, DO is congruent to CA, and I have quantities for both of those, right? So if DO is congruent to CA, that's just like a thought I'm having, right? Then 2x plus 1 has to equal 3x minus 2. Whoops. So 2x plus 1 has to equal 3x minus 2. I got those expressions from up here, right? So that's an equation I can solve for x. So let me solve for x, right? So I'm going to get x to one side, make it disappear from that side by subtracting. That leaves me with x minus 2. Add 2 to both sides to get x by itself, and I get x equals 3. Okay? Now, that's x, right? So now how x helps me is I can take x and I can plug it in to my side lengths, to all these given side lengths, and then that will help me fill in perimeter, right? So let me put x in for DO, right? So I'm going to do, 2 times 3 plus 1. So that's 2 times 3 is 6 plus 1 is 7. So DO is 7. That means CA also has to be 7, just by the way. Which, that makes sense because 3 times 3 is 9 minus 2 is also 7, right? Okay, Okay, what else can I do? Okay, AT is x plus 10. So let me put 3 plus 10 there. And I get AT equals 13. So that's 13. So that side has to be 13. All right, what about my last side? Oh, hey, that's 8. So this has to be 8. Now I have all three side lengths, so I can find my perimeter. So perimeter is going to equal 7 plus 13 plus 8. Let me actually compute that. So 7 plus 13 is what? 20 plus 8 is 28. So my perimeter is 28 units. All right. Hope that all made sense. Thanks for listening.